Hello everyone, welcome back to our channel. So as we are discussing the friction, we'll start the second part of the friction, that is block kept on the inclined plane. Now the plane is not horizontal, it is making an angle theta, that is 30 degree with the horizontal, and a block is kept on this surface. The coefficient of friction between the block and the surface is mu. Now we'll analyze this motion. So first we should draw the center. Second, we'll draw the x-axis. Now instead of drawing the horizontal x-axis, the x-axis should be parallel to the inclined plane. So it is making an angle 30 degree with the horizontal. Then draw the y-axis perpendicular to the x-axis. So it forms a new coordinate system. So this is your first quadrant, second, third and fourth quadrant. After this, show the weight force. Now showing the weight force is very important thing, because the weight force is not along the y-axis, it is perpendicular to the horizontal. So the value of weight force is equal to mass into gravitational acceleration. It is perpendicular to the horizontal. So many students make this mistake by showing the weight force vertical here, but show it as like this. Now this angle calculation is very important. For that you can consider this triangle. So one angle in this triangle is 90 degree, the second is 30 degree. So this angle is 90 minus 30 degree. So it is equal to 60 degree. Same angle here we can represent. So this angle is equal to 60 degree and this angle is equal to this angle 30 degree. So here we can assume that the angle of the weight will be 90 minus 30 degree. So just remember this point, the angle of the weight force with the x-axis is equal to 90 minus angle of the plane. Then show the normal reaction, it is along the y-axis. Then we'll analyze the motion. The block is moving in the upward direction because the force is acting on this block. So because the movement is towards right side, the friction force will exist towards the left side. So this is the direction of the friction force. And the friction exists between the contact surface only. So friction exists on the bottom surface only. That's why we can show the friction force opposite to the motion, and the value of friction force is equal to coefficient of friction into normal reaction. So in this way we have completed the figure. As per our discussion in the previous lecture, friction has only two components, means two additional force we have to show. First one is normal reaction and the second one is friction force. So normal reaction is always perpendicular to the surface in contact and it is towards the center and passing through the center. Friction force always act in the opposite direction of motion, and the value of friction force is equal to coefficient of friction into normal reaction. So FBD for this numerical is now completed by showing all the components. Now I will give you one more trick how you can simplify this figure. As per this figure, only inclined force is weight force. Remaining forces are N is a vertical force, F is a horizontal force, P is a horizontal force. So you can show it this figure as a horizontal block. So first draw the center, draw the x-axis, draw the y-axis. Now show the weight force. Weight force is only inclined force which is making an angle 60 degree with the horizontal. So this is the weight force, this is the angle 60 degree. Then we'll resolve this force. So y component and the x component. The y component or Fy component for the weight force is equal to W sin 60 and the Fx component will be W cos 60. So we can simplify this weight force into horizontal and vertical component. After that, show the normal perpendicular to this surface. Then show the friction force in the same direction like this one. So F is equal to mu into N. Applied force P. So this complete your figure. If you draw this figure in this way, it will simplify it and there is a high chances that you will not make any mistake while solving this numerical, because it is very difficult to imagine by observing this figure which is horizontal, which is vertical. One thing to remember is that weight force is only inclined force. So if you show it like this and show the angles, it will simplify your FVD and you will able to solve this question. Now the next thing is that we can apply the condition of equilibrium, that is summation of fx0, summation of fy0, and we can solve this numerical. If you found this video useful, you can like it, share it and subscribe to our channel. Thank you very much.